So one more example, and then we'll get to do lots of practice in class and lots of practice getting ready for the AP test. Just notice that you can still use integration by substitution to evaluate a definite integral. So here, this is the integral from 0 to pi over 3 of tangent x times secant squared of x dx. And I notice that I do, in fact, have a multiplication in my integrand. So I think about whether one or both of those factors is the derivative of the other. And I say to myself, oh, okay, so I know that the derivative of tangent of x is secant squared of x. So I'm going to let u equal tangent of x. My du is going to equal secant squared of x dx. And I'm going to isolate dx. I get du over secant squared of x equals dx. Now some of these problems, there's more than one way to do it. There's more than one u that you could choose. This is the u that occurred to me. And how do I know if it works? If I write a new integral, and it's an integral I can think of an antiderivative for, and I get down to one variable exactly, then I've made a good choice, remembering that there might be more than one choice that works. So here's the thing. I'm about to take my x integral and rewrite it so that it's written in terms of u. And that's totally legal. Just notice that the limits on my integral are x values. I can't leave x limits on a u integral. You have two options. I'm going to show you both. You're going to have to come to the time in your life where you make the decision yourself which you're going to use. So I'm going to show you one way to do this problem, which is to update your limits to become u limits. So I'm going to write a new integral. I'm not going to put the limits on yet. Everywhere I see tangent x, I'm going to replace it with u. Everywhere I see secant squared of, oh, well, I didn't make a new name for that, so secant squared of x. Everywhere I see a dx, I'm going to write du over secant squared of x. And I can tell this is going to be a good thing because my secant squared of x and my secant squared of x, the only two things that have an x left in them, are going to cancel each other out. I'm going to be down to an integral in one variable. It's going to be beautiful. And I still have this problem before I move on to the next step. I haven't updated my limits. If to get the u value, you tangent the x value, right? That's what this statement says. If I want to know what u is, I have to tangent x. So I'm going to use those two limits, the lower limit and the upper limit, as x values, as inputs to the tangent function. So when I'm going to write myself a little note, when x equals 0, u equals tangent of x, in this case tangent of 0, and tangent of 0 is 0. So my new lower limit is 0. And maybe that doesn't feel like a new lower limit because it happens to look exactly the same as the old lower limit, but it is. I've converted it from being an x limit to being a u limit. We'll have more excitement when we update the upper limit. So when x is pi over 3, oh wow, you're going to test Miss 6 and see if she remembers her tangent of pi over 3. So when x is pi over 3, u is going to equal tangent of pi over 3. Tangent is sine over cosine. The sine of pi over 3 is radical 3 over 2, and the cosine is 1 over 2, so that simplifies to radical 3. So once I've updated my upper limit to be a radical 3, I'm going to be able to simplify this integral. My new integral is the integral from 0 to radical 3 of u times secant squared of x, and that's secant squared of x. Here I'll use red. They're going to cancel each other out. And I'm just going to have, the only other thing in my integral is this du that I'm happy to have. Okay, so can I find an antiderivative for u? Well, that's u to the first. I'm going to use the reverse power rule. This is going to be, whoops, u to the new exponent is going to be 1 bigger than the old exponent. Divide by the new exponent. and I'm going to evaluate that from 0 to radical 3. So that's going to be radical 3 squared is 3 over 2 minus 0 over 2, which makes 3 over 2. This is one great way to do this problem. I got the answer 3 over 2. I'm going to erase the board and show you another way to do the same problem. So another way to do this exact same problem, that's not very different. I'm going to make the same substitution. I'm going to let u equal tangent x, so du is secant squared of x times dx, and du over secant squared of x is dx. That's me trying to isolate dx. That part's exactly the same. Now when I write the integral, just notice one other way I can do this. Instead of updating my limits, remember when I wrote what the u function was and I sort of plugged in those two limits to find new limits for my u integral? You could just leave the limits off until the very end. So this is another approach. I'm going to pretend I just want to evaluate this indefinite integral, and I'm going to do that by making this u substitution. That's going to be the antiderivative of u times secant squared of x times du over secant squared of x. I get that same thing where my secant squareds cancel out, and I'm down to this indefinite integral, which is u to u. That's not so bad. That's u to the first. So my result is going to be u to the second divided by 2. And I could write plus a constant, but now I know what I really want is to have my integral, my antiderivative, in terms of x. So I'm not going to put an equal sign because what I'm about to write is not equal to what I just had there. I could have put u squared over 2 plus a constant. I'm going to just sort of shift my work to a new place and say that, okay, well, if my original integral was I needed an antiderivative for tangent x secant squared of x, I found that, and it's going to be u squared over 2. So tangent squared of x over 2, and I'm going to evaluate that from my same original limits, 0 to pi over 3. Because I now have an antiderivative in terms of x, I better make sure I use x limits with this antiderivative. So what is my new function going to be? I'm just going to be tangent squared of pi over 3 over 2 minus tangent squared of 0 over 2. So that's going to be tangent squared of pi over 3. We reviewed tangent of pi over 3 a moment ago. Remember, tangent squared means find the tangent and square it. So that's going to be radical 3 squared over 2 minus 0 squared over 2 is going to make 3 over 2 minus 0, just 3 over 2. Notice I got the same result. The thing you want to be really careful about, especially in the free response section, because you will not get full credit if you ever write something that's untrue. If at any point you had left x limits on an integral that contained u's, you would not get full credit. If you, at any point you said that this expression, which is just a polynomial in u, it doesn't have limits on it, doesn't imply that it's being evaluated, is equal to this, that would not get full credit. Those are not equal. They're expressions that helped you, this one expression that helped you find the next expression, but they're not actually equal to each other. So just take care, the most important thing to watch for is not leaving x limits on a u integral.